So our goal in this problem is to convert this polar equation, which, as you notice, has a theta and an r in it, so that's how you know it's a polar equation, into a rectangular equation, meaning we only want it to have x and y's. Our formulas that we can do to help us. We know r squared is equal to x squared plus y squared. We know x is r cosine theta. We know y is r sine theta. So now all of these are a little different. You just have to kind of play with it, see what you can do. So as that previous slide said, two main methods are either squaring both sides of the equation to get to an r squared, or multiplying both sides of the equation by r. Now in this case, if we square both sides, yeah, we'd have an r squared on the left, but we'd have a cosine squared on the right. And we really wouldn't be able to do anything with that. So this would be a case where the best idea to go is to multiply both sides of the equation by r. Because what that does is now our left side of our equation is r squared. Our right side says 6r cosine theta. So now from here, we can set some things out. We know r squared is equal to x squared plus y squared. We know r cosine of theta is equal to x. So now we have x squared plus y squared equals 6x. So now with these equations, yes, technically we are rectangular, but we want to get these into a form where we know what the actual graph is. So if we get everything to one side of the equation, x squared minus 6x plus y squared equals 0, this should look very familiar from the unit we just did over conics. We have an x squared, we have a y squared, both their coefficients are 1, which means this is going to be the graph of a circle. So now to put this into the standard center radius form, we're going to go back to last chapter, complete the square. In this case, negative 6 divided by 2 is 3, squared is 9, add it to both sides. So this turns into x minus 3 squared plus y squared equals 9. So not only do we want to be able to switch out the r's and the thetas for x and y's, we also want to put these equations in a form that actually means something in rectangular equations. We want to know what the graph looks like. So for the next slide, you have about 5 of these to try. Try playing with them, switch them to rectangular equations, and then find out what type of graph it's making.